Hello Internet, it's John McDonald here, and I wanted to make this video to kind of address, this is going to be my first uh, video for, I guess, a programming tutorial, basically like a subjective one. I'm not going to actually teach any programming quite yet. I'm going to talk about a lot of things, like its relevancy, is it important, you know, and like how to get started, and then go from there. And I'm actually just doing this off the top of my head as well. There's no notes, no pre-planned anything, so forgive me if it's a little bit scattered. All right, but I kind of want to start off with the narrative you see a lot here, you know, and especially coming from somebody like a former NVIDIA CEO, where they say coding is dead, and that English will become the new programming language. So, is it worth learning this skill or not? You know, and it this kind of narrative, I see it quite a bit. It's actually, to me, very, very dangerous, you know, because I think it scares people away from the field, you know, like, oh, it's going to be, which, if you notice, any person that's worked in the field for any extensive length of time, like, you know, the people who are responding to this particular person's questioning holds a PhD in artificial intelligence. I have degrees and I have certifications in AI, and I've been programming for a very long time, right? So I understand this field pretty well. And this particular person here is a software architect as well, and you know, they both came to the same consensus that I would immediately come to as well. You know, he's either lying or ignorant about programming, artificial intelligence, or both, if he thinks software engineering, you know, is going to be replaced in the foreseeable future, right? Like, so now it's important to understand, like, you're going to see AI replace jobs in every field, okay? And with AI, it's going to impact software engineering jobs as well, right? Because there's a lot of mismanaged development out there, truthfully, and I think all professional, you know, developers, engineers know that, right? Like, a lot of times we end up having to work on things we shouldn't be working on, you know. Products incur things like technical debt, for instance, like where we're, you know, driven, you know, through motive of profit. Okay, so, you know, you work for, let's say, X, for instance, or Twitter or Facebook. You know, it's basically just a website that is trying to generate money. So you have to, as a developer, continuously work within the constraints and confines of that particular product. Yes, it can evolve as well if they have it structured, if it's done well, you know, they take a growth-oriented position. However, a lot of times, you know, you're hired on places to, you know, do routine maintenance, updates, maybe port a code base from one language to another, or a variety. There's a whole different variety of things that can happen. A lot of those things, however, AI could potentially replace, right, those roles, which would actually be a very good thing for any normal, sane developer, right? Because we don't like to deal with doing those things to begin with, right? So we're kind of hired on jobs to fix retrospect sort of problems. You know, we're not getting to work on the things we want to work on, and that's why, you know, you hear, oh, there's a, you know, at the same time you see, well, AI, and then at the same time you see there's, oh, well, we have a lack of programmers or engineers or whatever. And so simultaneously you have this kind of like fallacy, right? And, you know, what this particular guy's talking about is where you see, like, for instance, here, I typed this in on a simple, this is an AI model, you know, Copilot, like, for instance, if you wanted to generate a C program that produces quantum nonlinear optimizations, right? And I know it's not going to be able to do that, right? Simply because of the word quantum. So I'm already well aware of the limitations that AI has, and the next evolution of our shift in moving forward with technology, what that's going to be, right? Because we're essentially, and I'm going to get into this in a little bit here, we're essentially going to have to start all over again, for the most part, right? and we will absolutely need developers, because we're moving towards a field like, quantum computing and things, and quantum theory, where most people, admittedly, even myself, it's a very, very deeply technical field, and humans don't even understand to the fullest, and there's a lot of things out there like that. There's a lot of things out there, and those particular things AI won't be able to understand either, because AI is only able to learn what it has been programmed to learn, right? And so, and there has to be an existing knowledge base for it to train from, no matter what. Even if you want to try to create artificial general intelligence where it's able to go out and learn on its own, it's still going to need, just like a human being, some source of knowledge that was put forth before it by somebody else who would learn that. It doesn't have the ability, and that's where it becomes the differentiator between a human and a machine. It's kind of common sense to me. It's like it doesn't have the ability to go out and seek and have its own free ability to spontaneously generate anything it wants, right, from its own imagination. Okay. Hence, you have a whole new field of quantum computing, right? And within quantum computing, so here's AI, right? It will generate code for you. Okay, and this is where a lot of people are like, oh my God, it's gonna replace programming. No, it's actually a great helpful tool, because when you type in an English expression like that, okay, this to me is just simply a tool that augments my normal daily routine of coding, right? It provides me stuff that I don't want to do, that I have done a million different times over again, is write a gradient descent algorithm, write one of the many different design patterns, write, forms, how many like when you start to get into things like web interfaces and stuff like that, all this repetitive stuff that you're just stuck doing over and over and over again, because everybody wants this and that and this and that, right? It's going to be able to do those because we've done it a bazillion times, right? Nothing new here, and that's the beauty of it, right? It just helps. It's just an augmentation tool. It's not going to replace innovation. It's going to help accelerate it, in my opinion. Me, for instance, it allows me now to move faster in my development. It's actually made us, an individual developer, more powerful, to be quite honest with you. You can have AI get done and generate a lot of the things that you would normally have to do in the past, that would take up weeks and months of time to get this interface built and forms on all this stuff. Now you can have it just generated for you. It's there, it's ready to go, to move on to a much larger, complex problem. The field of innovation is in its infancy in terms of technology. Computers, these aren't 100 years old or less that this whole field is in. Okay, so moving forward, which is why you see things like this here, even AI will tell you that, like creating a program for a quantum nonlinear optimization, let's say. Now we're moving into a whole new field that hasn't even been fully developed or tested yet, which is going to need a whole new set of coding and a whole new set of programming, and ripe for opportunities to create languages and Q or whatever, however you want to call it, it's going to be built on that type of hardware. So it's unbelievable to me, the short-sightedness of people, in that instance, right? And so when you see, even with AI, will tell it to you, it literally says creating, quantum nonlinear optimizations can be quite, complex, and typically involves advanced math and concepts and specialized libraries. That's pretty much all I'm saying. With code, it's scouring Git repositories and things like that. And a lot of times you have to really check this stuff too. it's a good jump starting tool to help you get moving. It's great, but a lot of times it's not the best either. You got to be careful with this. So you have to, you can't just copy and paste and move into things. And that's kind of the other point. It's like, cool, it's generated this code for you. What now? You have to take that, put that into a program, go through the whole process, apply that program to the application that you're doing. Whether it's in hardware inside a car or, however it's going to be applied. There's so much more to it, right? And it's also interesting to know, they literally just tell you what, developers who've been around for a long time, we just call it literally libraries, and they're talking about, you would use quantum computing libraries for specialized quantum, which is what I'm getting at here, where you have these companies that are developing quantum hybrid specific code, right? And so you're definitely gonna be useful, right? There's just gonna be shifts towards where you're needed, I would say, and I think it's for the better, in all fairness. So it's absolutely a decent field to get into. I would caution, however, the way things are done with schools today, because a lot of schools will teach you proprietary products that are useless in 5 years. Sometimes they'll teach you hey, we're going to learn how to use this particular version of Adobe Macromedia or Flash, right? And we're going to learn how to program in Flash, because that's and so when you get into that kind of stuff, which is really old, or like when I went into computer science school, they were teaching Java Enterprise Edition 6, which none of the stuff is even in existence today, right? It's completely radically changed. I would say to learn the fundamentals, right? Learn a good language to start with, truthfully, is C and C++, because C teaches you good programming fundamentals that you'll be able to take all across, and integrate to the hardware. And then C++ is going to teach you a lot of the concepts of object-oriented programming, which from those two levels, moving forward, you're going to be able to easily move into other languages and understand things. Even assembly is a good thing to kind of put the glue together. So you learn the hardware, you learn assembly, you learn C, you learn C++, you learn those four things, and you study them and you understand how they work and how they communicate and all that. You'll be golden moving forward, right? All the other stuff is built on top of that abstraction, so you don't really want to start off trying to learn I think it's why a lot of people struggle to learn things like Python, because they're jumping into the top of the abstraction chain. And yes, it's easy and it's good, and those are tools that help people in other fields not have to deal with more complex computer science topics. But if you're a computer scientist person, or you want to be a computer engineer, or that's your field of focus, definitely start learning digital logic and how transistor to transistor logic works, and then that builds and how you can actually start to turn an opcode into voltages and things like that. So when you get there, just be prepared to understand that the future may be changing hardware as well. So anyways, that's all I got for now.